Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for lesson 3.2.3. This is where you formally get KFC into your math notes. Even though I've been talking about it for days now, KFC, or with the homework anyway. Another method for subtracting integers is to notice the relationship between addition problems and subtraction problems as shown below. So if we throw in the whole KFC into each one of these problems, you'll keep -3, you'll flip that to a plus sign, you'll change that to its opposite, you get the exact same answer. So take -3, remove 2 of those negatives, you're left with a -1. Take -3, add 2 positives, you get 0 pairs, you're left with -1. You get the same answers every single time. So this whole process, we call it keep, flip, change, KFC. If you've been at other schools, maybe they call it something slightly different, but this is what I call it. I'll refer to it quite a bit throughout all of 7th grade and much of 8th grade whenever a problem like this comes up. So, do we need to do KFC? Not always. In a situation like this, we're adding 2 integers together. Do you have more positives or more negatives? In this case, you've got more negatives, right? And how many more negatives do you have? Well, if you take 18 minus 6, you get 12. So you've got 12 more negatives than positives. And what's the model look like for this? 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. Those are the 0 pairs there, right? And then the rest of them that are left over are your answer. So you've got 12 more negatives than you had positives after removing the 0 pairs. Now, we want to just remember the rule. We don't want to have to use our integer tiles all the time, especially having to deal with fractions and mixed numbers. So now that we know what we do when we add positives to negatives together, we know that when you are adding a positive to a negative, you will do a subtraction, and you will keep the sign of the bigger number. So I would change this to probably 24 in 2 halves minus 12 and 1/2. So 2 halves minus 1/2 is 1/2, and 24 minus 12 is 12. And we had more negatives than positives, so we get a negative for our answer. Okay? Adding 2 numbers with the same sign, you add the numbers, you keep the sign. And in this case, I would probably do these first, add those together, and then do the subtraction at the end, because adding is always easier than subtraction, so I want to minimize the amount of subtracting that I would do. If I were to go from left to right, I would have to do a subtraction here and get a negative answer, and then do another subtraction from the 15.28. So I can, by changing all of this to addition, that allows you to use commutative property and add everything together in any order that you want. And so we would do these first, then do the subtraction at the end. Find each of the following products or quotients without using a calculator. Well, okay, we can do that. When you are multiplying 2 numbers that have different signs, you're going to get a negative answer. The reason for that is because of repeated addition. This is literally saying you got -3 that you're adding repeatedly 6 times. So here's -3, -6, -9, -12, -15, -18. So the more times you see this expanded out, the easier it is to remember the rules. When you're multiplying 2 numbers with different signs, you're always going to get a negative answer. And when you multiply 2 numbers with the same sign, you're always going to get a positive answer. And this model here, while that looks really confusing, this is repeated subtraction because of the minus sign being in front of the 8. Just think of KFC here, where you're going to add the opposite, 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 and so on and so forth, so that this eventually becomes 8 times +3. Now, another way of looking at it is this. If you agree with me that 8 times -3 has to give you -24 for an answer, and that minus sign in front of the 8 means to take the opposite of whatever 8 times negative 3 is. And so the opposite of negative 24 would be positive 24. Here it doesn't matter because you are multiplying a number times 0, you get 0 for an answer. And here, I wasn't quite sure what they were going at, so I just kind of did the reverse. Negative 20 divided by 5 is the same as 5, I guess, times negative 4 gives you negative 20. I don't know. I don't like E and F here, so if you didn't understand what to do there, but you knew that the rules for multiplying positives and negatives together was the same as the rule for dividing them, then you would know that when you are dividing numbers with different signs, you're always going to get a negative answer. And when you're dividing numbers with the same sign, you're always going to get a positive answer. So 4 times negative 9 is negative 36 because negative 36 divided by negative 9 is positive 4. Negative 4 times 5 is negative 20 because negative 20 divided by positive 5 gives you negative 4 for an answer. They're going to make us do this again. Oh, this is horrible. I don't like it one bit. Multiply these guys together. 4 times negative 2 1/3 is going to give you a negative answer. Negative 2, negative 4, negative 6, negative 8, negative 9, and negative 9 1/3 plus 7 1/6. Then you'd get a common. I hope you had more patience than me. I don't want to use up too much of my video showing you how to get all these answers, but I will show you the answers if you ask me in class. I will definitely show you the answers. If you're at home and you can't ask me in class, send me an email and we'll set up a Google Meet and I'll talk to you over the Google Meet and show you exactly how to get these answers. But in the meantime, just look to see, did you get the correct answers? Do you know how to use the order of operations and how to add, subtract, and multiply positive and negative numbers? That's what this is testing you on. All right, let's keep going through the fraction operations. You can either get a common denominator or you could use coat of arms. But these are the answers, okay? In this case, you might as well use the coat of arms because the common denominator is already 60. So 5 times 7 is 35. 12 times 2 is 24. 35 minus 24 is 11. This is the answer in simplest form. When you're multiplying, same idea. No, not same idea. We don't need a common denominator. What was I thinking? When you're multiplying, you just multiply from left to right, numerators and denominators. And if you can find common factors in the numerator and denominator before you multiply straight across, you can. In this case, turns out 2 and 8 also had a common. You could have canceled out a 2 there and a 2 there to give us 1 over 4. So if you choose to, you can just multiply straight across and then simplify. Or you can do cross-canceling in advance to make it a little bit easier. Here, I guess we could change that to a 1 and change that to a 2, so you end up with 7 over 10. Or just multiply straight across, and you would get 28 over 40. And then at the end, divide the top and the bottom by 4 over 4. Nathan wants you to solve his puzzle. I am thinking of a number, so there's his number. If you divide my number by 3, that's why we wrote it as a fraction, because that's a division problem, and then add negative 3, you get 4 for an answer. So what I typically want to do in this situation is I want to say, okay, what was the n minus 3 before you added the negative 3 to it? So remember, when you add a negative 3, that's the same as saying minus 3. So what number do you take 3 away from to give you 4 for an answer? That must have been 7, because 7 minus 3 is 4. And 7 plus a negative 3 is 4. So that means that n over 3 must have had a value of 7. So now we're taking a number and we're dividing it by 3 to give us 7 for an answer. What number do you divide by 3 to give you 7 for an answer? Well, that's got to be 21, since 21 divided by 3 is 7. So that's how we know the answer is 21. Now let's walk through this process algebraically. We have this process where whenever we are trying to rewrite an equation, we need to do the same thing to both sides of the equation. We want to keep everything balanced. You treat an equation as if it were a scale, where everything on the left side has to be equal to everything on the right side for it to stay balanced. Oh no, I didn't want to do that. Let me go ahead and get rid of this now. So I'm going to do something that I refer to as adding balanced sets. I will add the same amount to each side. And so if you think of a scale where if both sides of the scale are exactly the same, everything is even. If I add 3 pounds to one side, it's no longer going to be balanced. But if I add 3 pounds to both sides, then both sides still have the same weight, so they're still balanced and even. So this is a legal move algebraically, where this forms a zero pair. So you're left with just n over 3 plus 0. So we're just going to write it like this. But on the right side, we now have the 7, and that's what we have here. And now you've got to do the same thing to both sides of the equation. So what can I multiply times this to cancel out the denominator? Well, it turns out if I multiply the left side times 3, and I use a little commutative property, this becomes 3 over 3, which is a giant 1, times n over 1. So this cancels out and leaves you with n divided by 1, which we all know is the same as n. But you can't just multiply the left side times 3. You must also multiply the right side times 3. So that becomes equal to 21. So that means that n had to be equal to 21, which is what we set up here when we were just using plain logic. So I like for you to solve equations using logic. But we understand that there are going to be times when the mental calculations are too complicated. So we can use our calculators and work through the algebraic process to eventually get to our answer. And of course, you'll learn about checking your answer. Let's make certain that this works. Was it Nathan? Yes, if Nathan's first number was 21, he divided it by 3 and he got 7. And then he added -3 to that to get 4 for an answer. Is that what we get for our answer? Yes, it is, which means we know that our answer is correct. And that does it for today's homework. All right, let's move on to the next activity. Take care. Bye.
Hey, feeling good, like I should.